Activity 1.2, making predictions. Okay, now we got a table. We're going to continue on with the same concept, getting the table, writing our equation, making predictions, and all these terrific things. Now, reading with the question, what is the range? First off, we got to remember that our range is our y value. We should have learned this a while back, that domain is x and range is y. Write that little note real quick for yourselves. Now, the issue we might come across in this little part is, how are we going to decide from this table which one is our x value? Well, looking at this table, I can analyze that, hey, I can't have multiple numbers in these years, meaning I can't have a whole bunch of x's representing one temperature, because remember, repeated x's is not a function. So they took this set of years, which is 57, 58, 59, 60, and 61, and they said during this time we're going to talk about it as one place value. So this is going to be our x. This is just corresponding to that one representing that set years that's given. So since this is our x, this is our y, and now we could talk about the range is all these sets of numbers. If I were you, because it does look like it's going to turn into a line, I would have it as inequality maybe, or if you just want to go with saying, okay sir, I know it's 57.250 all the way to the end of this number, that is definitely up to you. Okay, there's a little sentence stems. The range is however you want to write this out. Next, let's identify the independent and dependent variables. Remember, independent is our x, dependent is our y. Our independent, if we look right here, okay, we're talking about x, that's our span of years. So we can definitely write that, our span of years. And our dependent is our average temperature. Does the data represent a function? Now, you can remember that our functions are represented by our x values connecting to our y values. Our input always has an output. A dependent has an independent, and all that great stuff. So if you think that this is a function, definitely describe why. Put yes or no, it is a function, as you like. Yes or no, and then blank, 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 blank. We want to see your point of view. If so, describe the function. If not, describe why not. That's another piece where we do want you to see, how do you know it is a function? You could put yes or no because blank, blank, blank. Use technology to graph a scatter plot demonstrating the relationship between the span and temperature, What association do you notice? So let's graph this real quick. Grab your decimals, let's input all our x's, let's input all our y's. Definitely pause the video because it will take me a good amount of time. I'll work as fast as I can, or I'm sorry, not pause the video, but what's the word? Speed up, fast forward the video, because I don't want you getting stuck just looking at me typing. So fast forward. Of course, I wish I did the whole YouTube editing, all that great stuff, but I'm not that advanced as some other individuals. I'm gonna double check to make sure I'm inputting it correctly, which is why I want you to go ahead. $57.445, 57.780, 57.700, 58.053, 58.262, 58.244, 58.448. Okay, hopefully it comes out exactly the way it should. When you zoom out, you see that all our points are going like this. So what type of association do you think we have if we have all our points going in the upward direction? Do you think it's positive, negative, or there's no association? I notice blank, blank, blank. Tell me if it's a positive or negative in your opinion. Number 5, I'm not going to waste too much time, but we want you to see where there's a decrease. When does the number go down? Okay, so definitely it's right. Another sentence then. I noticed the temperature decreases blank, blank, blank. Okay, take the time. I'm not gonna do everything with you just because we do want you to try and do it on your own, but make sure you have the table ready. Moving on to the next page in 5, 4, 3, 2, 1. Okay. Number 6, using your graphing technology to determine the linear equation, boom, 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 then sketch the data points. Of course, I have my data right here. I would love to make sure we can graph that beautifully, but because I just want to go with the flow, I am just going to sketch. We would love for you to label the axes a certain way. We would love for you to be able to recognize what number is going with what number, but for timing, we're just going to approximate. I'm just going to put approximated graph. So we should see a pointer here, 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 here. It doesn't have to be beautiful. Of course, if you want to take the time to make it beautiful, definitely do that. Now, what is our equation? Coming back to Desmos, I do want to use my little regression form. Y1 tilde mx1 plus b. We have all that wonderful information. We even saw a line pop out because that's a line of best fit. This line is a prediction of where the next point will fall, okay? And it is a very strong correlation, so correlation coefficient, so we know we're doing okay. Slope is 0.13, I'm rounding up, and my y-intercept is 56.86. Write that down. My slope is 0.13, we round it up, and my slope intercept is 56.86. Let's write out this equation. If I'm replacing my m and my b, let's do it real nice and neat. Y equals 0.3x plus 56.86. This is our guy in charge right now. What is the relationship between the equation for the line best fit and any association you notice in the graph? Do you think the line fits the data? Yes. We just looked at this on my screen. Let me zoom out. We can see that we have our set valued points with our line best fit cutting through approximately even amount. So we got the same on top, the same on the bottom, and some of them are even touching the line. And if we look at the correlation coefficient, our R value, 0.96 is a very strong correlation coefficient. So we're doing a great job. So I noticed blank, 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 give your own opinion. I would love to go over this wonderful information, but I am going to skip this just because I want us to just understand the mathematical meaning behind it first before diving into all this extra stuff. So our f of x is our y, so I'm rewriting the same exact thing, equals 0.13x plus 56.86. Now, we talked about this right now. My x is my input. There's my input, there's x, boom. I just mentioned that a little while ago. So if x is my input, my y is my output, which just turned into f of x. So f of x is my output. 0.1259, which is what we did to round up. This is my slope, but this word bank has something else. Rate of change. That's a very important word that we need to remember, because next week you'll be talking purely about rate of change. If you need to zoom in, please zoom in. Let me fix it so I could zoom in. And then my last part, 56.86, is my y-intercept. Very cool. This is a very nice lesson. Number 9. Use your linear regression equation to predict the average global temperature for the years 2032 and 2036. This is a good star level question. It's a little higher than star, but it's great to know what exactly we're aiming for. So 2032 to 2036. Now, the issue with that is on my table, 2032 seems a mile away. So we do have to count, and I want us to be able to do this together, so I'm going to take it nice and slow. So my next value, 13. That is from 2017 to 2021. My next one is 14. That is from 2022 to 2026. 15. That is from 2027 to 2031. Here we go. 16. That's my number. I don't want to really write on top of that, but okay. 2032 to 2036. We actually worked it out. We found out what our x value is. Let's find out our y. Okay, coming back to decimals, let's type in our equation. Equations, we already rounded it. Let's just type it out. Y equals 0.13x plus 56.86. Okay. I'm gonna do the table stuff, so I'm gonna click the gear. Table. I don't like all this stuff, so I'm gonna erase it just to make my life easier. And we're looking for the number 16, so I'm gonna type in 16. 58.94 degrees. Which makes sense, because if we look at right here, 58.448, that means it's still increasing, and obviously we're having a positive association, so we know we did a pretty good job. Wonderful. Let me leave it right there. Give you a second to look at that. Next video will cover the last activity, and we'll be done for the day. Thank you.